Hello, welcome to section 2-2. We are going to look at basic graph shapes. And graphing is one of my favorite things, so I'm pretty excited to go through this material with you. Before I do that, let me say a little something about memorization in this class. There are certain things in pre-calculus that are going to be very important for you to have memorized in pre-calculus. I do not believe in memorization for memorization's sake. The things that I ask you to memorize are things that you're going to need in your brain to access for calculus. So they're really important. If you choose not to memorize the things that I ask you to, you will have trouble in calculus. You will struggle at certain points along the way. So I would highly recommend that you get out some note cards, and anytime I tell you to memorize something, put it on a note card. One side put the thing, on the other side tell me what it is, and just go through those on a weekly basis and keep those fresh in your mind. You're really going to have an advantage in calculus if you do that. And I will remind you of that along the way. We're going to go through basic graph shapes, and these are things that you definitely need to memorize. Okay, when I give you a basic graph equation, you should have a picture pop up in your mind immediately. So if you're doing note cards along the way, what I would, let's look at this one first. We're going to look at f of x equals x squared. So what I would do on a note card is on the front, I would put f of x equals x squared, and then on the back, I would draw the picture. The picture looks like this. It goes through 0, 0, 1, 1, and negative 1, 1. Those are kind of the important points. Now, if you want an extra point, it also goes through 2, 4, and negative 2, 4. But this graph is a parabola. It is not pointed at the bottom. It's rounded, and it goes up like that. So anytime, now what is important about this graph, what makes it this shape is the squared right here. So anytime you have something where the highest power is 2, it's going to look like this parabola. So then any kind of equation that has that x squared, you're like, okay, I know this is roughly a parabola, and that's going to help you greatly in calculus. So that's the first one that you should memorize. The second one is y equals the absolute value of x. Anytime you have an absolute value in a function, what that does is it, oh, these are off center. Hold on. Let me move these over. They're not lined up. There we go. Absolute values are v's. These graphs also go through 0, 0, 1, 1, negative 1, 1, but they go out in a straight line. So they don't go then 2, 4, they go 2, 2. So they look like this, a V out here and a V out here. Now, this V can move around depending on the equation, but this is what we call the parent graph. The basic graph shape is a V. So anytime you have a function with an absolute value in it, it will be some sort of V moved around somewhere, okay? The next shape that I want you to know is f of x. Oh, I used y over here. Let's just keep consistent. It doesn't matter if it's y or f of x, but f of x equals x cubed. This graph does, it goes through 0, 0, 1, 1, and negative 1, negative 1, and it kind of goes through at a 45-degree angle. So that's kind of the pitch of that line. And then after that middle section, it goes up very steeply, and then down very steeply. So it kind of, what I say is it has like a little wiggle in the middle. It's a sideways thing and then goes up. For frame of reference, this goes up probably a little steeper than I drew it. At 2, you should be at 8. So as opposed to this parabola where at 2 we're at 4, here we're 2 at 8. So it goes up much steeper, quicker on this graph. So anytime you have a cube in there, you've got some kind of wiggle. Now there's some exceptions to that rule, and we'll talk about that in later sections, but this is the parent graph for x cubed. The next one that I want you to know is f of x equals the square root of x. So this goes through 0, 0, and 1, 1. Okay, and it looks like this. It's very flat. For frame of reference, at 4 you should hit 2. So this is 4, 2. So if you want to understand how flat it is, but that's the rough shape, and that's what I want you to be able to do, is sketch a rough shape of it. Okay, and then f of x equals 1 over x. I'd like you to know what this looks like. This guy's off center too, sorry. Let me move him. Thought I got them all on the lines. Okay, this one goes through 1, 1, and it looks like this. And then it goes through negative 1 and negative 1, and it looks like this. Now, something that we'll talk about later, but just so you know, there's an asymptote right here, and there's an asymptote right here. What an asymptote is it's a line that the graph is kind of magneted towards, but doesn't ever touch or cross. So the graph is moving towards the pink lines, but it's never going to actually get there and touch. Okay, so these are kind of the basic graphs that I want you to memorize. And what we'll do in further sections is we'll talk about how to shift them and those sorts of things. So for your homework's sake right now, I want you to practice knowing those. And then when they give you one of these basic graphs that is shifted, what I want you to remember is your skills from Algebra 2. So let's take, for example, f of x equals x squared plus 1. If I ask you to graph this. So what I would say is, okay, well, the highest power here is 2. That's a squared. So I'm looking at this parent function. It's going to be some kind of parabola. But this 1 is going to move it somehow. We'll talk about what that actually is doing later. But for now, what I'm doing is I'm just going to make an XY chart. I'm going to pick a couple values and plug them in. And there's no right or wrong with what x values you choose. But you just keep choosing x values until you can identify where that parabola is. As soon as you see where that's turning, then you're done and you can draw the graph. So, I don't know, I usually start with like -1, 0, and 1. Those are great numbers to start with. And what we're doing is we're plugging those numbers into the function. So I've got, if I'm plugging in -1, I've got -1 squared plus 1. So this is going to be -1 squared is 1, plus 1 is 2. So this guy is 2. Now I'm going to plug in 0, and you can do this in your head. I just want to write it out for you so you see what I'm doing. 0 squared 0, plus 1 is 1. And then if I plug in 1, then that's going to be, again, 1 plus 1 is 2. All right, now I'm going to plot those points and see if I can figure out what's going on. So -1, 2, 0, 1. And 1, 2, and look, I've already got the start of what I know should be a parabola, so then I can go ahead and sketch the graph. The rest of the graph's an estimate, and that's fine. I'm just looking for a general shape. So it looks like that's a parabola, and it shifted up 1. So that's how I want you to attack the homework problems when they ask you to graph. If they're not parent functions, just plot a couple points, understand what the shape is, and just try to find where that shape is. All right, next we are going to look at functions called piecewise functions. These are functions that are broken up into sections. So they have these little brackets here, and they'll have 2 parts to the equation. So for example, x squared, when x is greater than 1, and 2x plus 1 when x is less than or equal to 1. Okay. So, and then the directions say to graph. All right, so here's how you do these. You're going to take each of these graphs. There's several ways to do it. I'm going to show you one way. Okay, if you can do, some people can do these in their head, and that's great. You don't have to go through all these steps if you don't want to, but what I do is I take each of these functions, that one and this one. There's 2 different functions, and I graph them separately. Okay, so I look at the first one, I go, okay, let's see, fx equals x squared. Oh, wait, I know that one. That's my parent graph right here. Okay, that's a parabola, and it's centered at 0, 0. So I'm going to do that. Now it helps with these graphs if you're a little more accurate. So I'm actually looking at this 1, 1 and 2, 4 and trying to hit those on the nose. Okay. For the other ones, you can sketch a little bit looser. So that's my pink part of my graph. Now I'm going to take the other one and graph it. What is this? Okay, we probably need to review. This is a line, and you drew these in Algebra 1 and Algebra 2. So let me write this out first, just this part of it, 2x plus 1, and let's talk about how to do this. We'll remember, this is review. So the first thing is you take the number that's sitting by itself. This is the y-intercept. And you plot that point on the y-axis. This is the y-axis. One of the most common problems is people plot these on the x-axis. So be careful and find positive 1 on the y-axis. It's right here, okay? And then this number right here in front of the 2 is the slope. And the slope wants to be in fraction land. So since it's a whole number 2, I write it as 2 over 1. And this is how much you go up or down, depending on the sign. If it's positive, you go up. If it's negative, you go down. And this number down here is how much you go right. That's one way to think about it, okay? So, and you're doing that from your y-intercept. So from this one point, I'm going to go up 2 and right 1 and put a point. Okay, so this is my 2, this is my 1, and then I'm going to draw this line. So it looks like that. Okay. Now, this value over here, these numbers will always match. This is kind of like your dividing line. It's an x value because it says x. And the x equals lines are vertical lines. So if I have x equals a number, that's going to be a vertical line at that number. That's how you graph those. And so x equals 1 is right here. And I don't know, you can draw it however you want, but I usually draw a dotted line. And what this does is it divides your graph into left and right. Okay? And these inequalities tell me, am I looking at the left or the right? So let's look at this one. This says x is bigger than 1. Bigger numbers are to the right. So that means that I want the pink graph on the right side of the line. Okay? So if the pink graph is on the right side of the line, what I do is I go in and I erase the left side of the pink graph. Okay? There we go. So this is all that's left of the pink. Nothing on the left-hand side. For the bottom one, it says x is less than 1. Less than numbers, less is on the left, more is on the right. So this says that the blue graph is on the left side of the green line. So I'm going to go in, and that means that the left side of this line is going to stay, but the right-hand side is going to get erased. And I'm going to erase this 2 and 1 also, just so I don't get messed up, okay? So all I have is this part of the blue line on the left. So it cuts the graph into pieces, which is where we get the name, the piecewise function. Now, the green line that I drew is not actually part of the graph. I draw that as an aid, and as you get better at these, you won't need the green line. So I just go in, if I drew that, if that's helpful, that's great. I just go in and erase that when I'm done. So you really want to be using pencil on these guys so you can erase. So that's what this graph looks like. Now there's one more detail that you need to pay attention to, and that is this is a greater than sign, and this is a less than or equal to sign. So this line under means that this is a closed hole, and this one not having the line under the inequality means this is an open hole. Just like you were, remember when you were graphing things on a number line in Algebra 2 and you put a closed hole or an open hole? It's the same idea. So the blue graph actually gets a closed hole, okay, and then it goes down here. And the purple or the pink graph gets an open hole at the end, and it goes up from there. And that's what the graph looks like. Okay, you can try some of these. These are not easy, so take your time and be patient with yourself. And we'll do some more practice in class on these. The other thing that you're going to do in your homework is you're going to go the other direction. I'm going to draw a graph, and then you're going to write an equation, okay? So let's take a look at that. Okay, let's do this one. And the directions would say, write the equation of the line. All right, again, what I do is I look at both of these as a whole graph, okay? And you can start with either one. Let's start with this bottom one. Okay, we're gonna make that pink. It's got an open hole right there, and it's a line. So when I'm writing the equation of a line, I am using this formula. This is my slope, and this is my y-intercept. So in order to write the equation of a line, I need to first figure out where does it cross the y-axis. Well, that's happening right here, this point here, and that point is -2. So this b value is going to be a -2. And then I need to figure out the slope. In order to do that, you pick 2 points, any 2 points that you can see where they cross. So let's say here and here. And you're going to count how much you go up and how much you go over. That's the slope. So here I'm going up 2 over 1. So my slope is going to be 2. And then I keep my x in there, and it's a y equals. That's the equation of the pink part. Now, as far as the sign of the slope, how do you know if it's positive or negative? We always read graphs left to right. So, and the way I think of it is a graph is a roller coaster. So you always get on the roller coaster on the left-hand side, way over here. So I'm on the roller coaster here. Okay, here I am on the roller coaster, and the question is, am I going up or down? And if I'm going up this roller coaster from left to right, I'm going up. So that means it's a positive slope. If you're going down, like if the line is tipped this way, then the roller coaster would be going down, and that's a negative slope. So that's how you decide what sign is on this slope part. So ours is a positive. All right, we'll erase our guy here. And then we move on to the other part of the graph. So here's this one. Now, in order to figure out where this graph crosses the y-axis, I need to extend it. So I'm going to keep the same slope. If you look at the slope, I'm going up 1 over 1. So I'm going to keep that same slope and extend this out like that so that I can see, oh, it's crossing here at +1. So my blue line is going to be y equals, my y-intercept is 1, and my slope, I'm going up the roller coaster, is going to be a +1x. You don't have to write the 1 there, but that's just for fun. So it's y equals x plus 1. That's the equation of that line. All right, now I'm going to erase my little extensions because they're not part of the graph. And now we're going to put it into a piecewise function. So I'm going to write f of x equals brackets, and it doesn't matter which one you write first. So 2x minus 2 and x plus 1. And now you have to tell me which side of the graph is this on. So the first thing we do is we look for our dividing marker. Where do they split? Well, it looks like they're splitting right here. So this number is 1. So I'm splitting at 1. And the pink graph is to the left, and that is the less than. So x is less than 1. And the blue graph is to the right, so that is x is greater than 1. Now, which one has the open hole and closed hole? If I've drawn over it, but if you remember in the original, this pink had the open hole and this had a closed hole. So that means that the pink graph is strictly less than, but the blue graph is greater than or equal to. And that's it. That's how you draw that. Okay? So a couple homework problems asking you to do that. And then the other thing that I want to tell you in this section that's kind of helpful with these piecewise drawings is I want to remind you how to tell if a graph is a function. Probably several of you remember that from Algebra 2. F of x is a function if it passes the vertical line test. All right, let's remember what that is. If I have a picture, a graph, and let's say it looks like this, okay? The vertical line test says take a vertical line and pass it through this graph everywhere, all the way along. And if all of those orange lines only ever touch the graph one time, then that means it passes. So this is a function. Let's compare that to this graph right here. If I pass a vertical line through this, it touches 2 points at a time. This is not a function, okay? Now, why do we care? Because in calculus, all the theorems in calculus are based on f being a function. And so everything that we look at in this class, we're going to talk about, is this a function or not? It's really one of the fundamental ideas in this class is that everything's built off of functions. So we need to make sure that every time we're using this notation, f of x, we are actually talking about a function. Which brings me to one of the best ways to check these piecewise graphs. When you're done drawing a piecewise function, check to make sure it is a function. See this, f of x? That means that you should be able to take this drawing and you should be able to draw vertical lines through every part. Now look, what about this transition? It's only touching 1 point at a time because this dot is closed and this dot is open. So it still passes there and here and here. So this is a function. One of the biggest mistakes that people make in drawing these is if you, they'll take their drawing and they'll draw the blue line here, and then they'll keep the pink line on the left, so it'll look like kind of like this. So they won't put the pink line on the right, they'll put both of them on the left. Now look at what happens when you go back and check. Boom, this is not a function. You've got both pieces on the same side. So you need to make sure that one piece is on one side, one is on the other. That's what makes it a function. So I would suggest every time you look at a piecewise function, at the end of the day, you just check really quick to make sure that it is a function, right? And then I think in addition, you'll have a couple problems on your homework that just ask you to verify if something's a function or not, and you're using the vertical line test for that. So that is section 2.2, and I'll see you in class.